Again, this was not assigned, but I think it makes a nice example that kind of demonstrates the ideas in 21 through 29. This is section 3.2. And so the polynomial they give me, they say p of x equals 6x to the fourth minus x squared plus 2, and they say c equals negative 2/3. By the way, is this a polynomial you guys would know how to factor? No? I'll show you a trick. Let u equal x squared. This is a trick that you'll learn about both in this class and in others. It's called u substitution. You make a substitution to make the problem easier to look at. Okay? So if I do that, now I can write the polynomial is actually 6 times, well, I'll get to that in a second, minus u plus 2. Okay? And then, do you guys know what I'm going to put instead of x to the fourth? Well, if u is equal to x squared, then what can I say? U squared would be x squared squared, right? But what's x squared squared? X to the fourth. Okay? And what happens is you get this trinomial. So I guess my question is that one you guys would know how to factor? Yeah, it is, right? Because we could say that this equals, how would you want to split it up? Well, how would you split up the 6u squared? 2 and 3, right? So I'll write 2u here, and I'll write 3u here. Ah, it doesn't quite work. It almost works. Right? The problem is that plus sign. Anyways, this is a trick that can help you sometimes, okay, is this u substitution idea for factoring. So in my example here, here's the polynomial. They tell me c is negative 2/3. And so what I've been doing is, I've been divide the polynomial by what? Well, we've been dividing by x minus c. Does that make sense to you guys? So in this example, what's going to happen? I'm going to take p of x, and I'm going to write it as x minus c times, the book calls it q of x, plus r. Okay? But, and how many of you guys, when I write these letters, have an idea what I'm talking about? Let me see. Aha, so that's my issue. Okay, start all over again. Let's go to this problem. It's Monday, not Thursday anymore, right? So it's been a weekend. So let's do this. Let's go back to 125. We're going to divide that into, let's say, 4,600. Now, let's make it 4,852. Okay. 4,852. That looks like 41,000. One more try. 125 into 4,852. What do you do first? I better pause this. This is embarrassing. So I'm going to walk us through this. What are you guys putting up here? A 3? 3 times 125 is 375, and I subtract, and I get 110, and I compare, and make sure that's smaller, so I did it right, and I bring down a 2, and did anyone give me another number up here? No? 125 into about 1,000. Around 8 maybe? It's a good guess, huh? Let's see. If we put in 8 times 125, well, I get 800, and then 8 quarters is another 200, right? $2. So I get 1,000, right? 8 times 125 is 1,000, and I subtract, and I get 102. Now, what's strange about what just happened is when we do our problems, what we're doing is we're doing a polynomial divided by x minus c. That's what our problems look like in Chapter 3. Although a lot of times we haven't done long division, what have we done instead? Synthetic division, just to speed it up. Okay? But this is what our problems look like. And what we get for an answer is we get up here q of x. What does q of x stand for? Quotient, that's right. So this is called the quotient. And then, way down here somewhere, sometimes we get something we call r. And what is r? That's the remainder. And you might say, well, what am I doing when I write this equation? I saw it in the book. I saw the answers written this way. What's really going on? And I think the only way to really understand it is to go back to a long division problem with numbers in it, like here, okay, in green. And so I want to rewrite in green what I know. And so the green one can be written this way. 4,852. That's my p of x. Are you with me? Okay. What if I told you it equals, well, instead of x minus c, which usually is on the outside, I have 125. 125. And instead of q of x, what do I have in my long division problem in the green? I have 38. And by the way, if I write that right now, what would you tell me? True or false? Does 4852 equal this? Well, no way, because 8 times 5 is 40, so it's going to end in 0. Right? The way to get it to work is you have to add on what after that? The remainder, 102. Now, here's another point. When is x minus c a factor? When is x minus c a factor? You know the answer to that by now. I believe that. Our class knows that. Talk to each other about that for a minute. When is x minus c a factor? We got it. When the remainder equals 0. Because, guys, look what my rectangle equation becomes. It would become p of x equals x minus c times q of x. Well, if this is plus 0, you could forget about it. See, x minus c really is a factor. X minus c times whatever this q of x is equals p of x. Does that make sense? Yeah? Okay. Well, what the remainder theorem says is this, and this is actually pretty powerful. The remainder theorem says, if I want p of c, I simply divide by x minus c and look at the remainder. What's that? That's a good question. It's going to be whatever your remainder is. Now, when people did this problem on the homework, here's one of the things I saw happen. What problem? Well, again, we did 21, 25, and 29. I thought I would do 28. So 28 says P of x equals 6x to the fourth minus x squared plus 2. And they tell me C is negative 2/3. So what they're saying is, the problem says basically, we want to find P of negative 2/3. Okay? Find P of negative 2/3. Okay. Here's what a lot of people did. I call it the hard way. P of negative 2/3, we know that that equals 6 times negative 2/3 to the fourth minus negative 2/3 squared plus 2. It's not that hard. You could do it. But do you see the issue is that we have to take this fraction and raise it to the fourth power and then square it? It's going to take some computation. Are you with me? Conceptually, it's not that hard. What I'm supposed to do, though, for this problem is I'd like to use the remainder theorem. Okay? But I have to understand it, and I don't think we did. So I want to talk about it. I simply divide by x minus c and look at the remainder. Okay, well, how do I do that? Well, in the box, what am I going to put up here? Almost. Negative 2/3, right? You put whatever c is. You put whatever c is. In other words, I'm checking, is x plus 2/3 a factor? That's another way to say it, right? But the remainder theorem says even if it's not a factor, this is a really cool tool. And you'll see how this works, I think, in a minute. What numbers am I going to write across here? Well, 6, and then some people missed this. Do you know what the next thing is? You need a 0 because there's no x cubes. And then what do I put next? We got to put a -1, okay? Always check the coefficients there with the signs, too. And then a 0, and then a 2. All right. And now, from what I've seen, people are pretty comfortable with the add and multiply. If you still are having trouble doing what I'm about to do, see me after class. Don't leave. All right? So I'm going to add 6. I'm going to multiply. Negative 2/3 times 6 would be negative 4. I'm going to add. I'm going to multiply. Negative 4 times negative 2/3 is going to be, well, it's going to be positive, right? 8/3, okay. Now, 8/3 and -1, that's 8/3 and negative 3/3, so I can write that as 5/3. Okay? 5/3 times negative 2/3, I guess that'd be negative 10/9. Add, what do I get? Negative 10/9. Multiply, what do I get? Positive or negative? So I guess it would be 20 over 27. So I guess the answer is whatever 2 plus 20 over 27 is. Okay? And yeah, you could simplify that to 74 over 27, if you like. Now, what the answer is, that's very interesting, that would be the answer to this. And actually, if you work it out, here's your 2. And all you have to check now is that the rest of this stuff adds up to 20 over 27. I have one problem with this. It looks like magic. I don't like to teach magic. I like to teach mathematic. Okay? So I want you to pay attention to one little step here about why the remainder theorem works. And that's this. Normally, what we do is we write, let me write it again, the rectangle above. There it is. P of x is x minus c times q of x plus r. Now, what am I finding? I'm finding P of c. Well, how do you find P of c? Well, you write P of x down just like we did above. But everywhere it used to say x, what am I going to put? I'm going to put a c. So see where that x is? I'm going to put a c. And where that x was, I'm going to put a c. Well, if you do that, what do you notice? Do you see how you get c minus c? What's that equal? So P of c is going to equal 0 plus the remainder, which is the remainder. That's how the remainder theorem works. Because we always can write this equation, x minus c times q of x plus the remainder, when you divide by x minus c. The quotient is not 0. You're right. It would be 0 times whatever q of c is. But what's 0 times q of c? Still going to be 0. I'm going to add 0 to r. It shows you that no matter what you divide by, what you're also doing is figuring out what the polynomial equals at that value. Okay? So this process that we're doing here is called synthetic what? Okay, division. But I've also seen some books call it synthetic substitution. Because all you're really doing is you're looking, what happens when I plug in this value? Well, if I get something, that's the value. That's P of c. That's P of negative 2/3 for this problem. Okay? So if you didn't understand that before today, I probably handed back the homework with a 2 on it. You probably got something circled, or some of you haven't turned in the Section 2 homework yet. I would go back to the problems in the 20s and try a few of these to make sure you understand that concept.